Good morning, everyone. Welcome to today's lecture, which is on resin bonded bridges. So today we'll be discussing about the indications and contraindications, advantages and disadvantages, classification and fabrication of resin bonded bridges. So to introduce, resin bonded bridges are also called as resin retained bridges, minimal preparation bridge, or an adhesive bridge. So conservation of tooth structure has been one of the main goals of restorative dentistry. Conventional procedures for the preparation of abutment teeth often involve major removal of tooth structure. If coverage is necessary for cosmetic purposes or because of caries or pre-existing restorations, this removal of structure is acceptable. However, when the abutment is sound, conventional full coverage procedures seem quite radical. More conservative procedures, such as partial veneer crowns or pin retained crowns, present limitations in aesthetics and retention. Many patients object to these drawbacks and consequently choose removable partial dentures, which may not be used. Recent innovations in acid etch technique have led to new alternatives to traditional treatment for aesthetic and restorative procedures. So these minimal preparation bridges are therefore used when the potential abutment are unrestored or minimally restored and there is a need to reduce unnecessary tooth preparation. Design options possible for the resin bonded bridges are the cantilever bridge, the fixed bridge, the fixed movable bridge, and the hybrid type. Coming to definition of resin bonded prosthesis, according to the glossary of prosthodontic terms, a prosthesis that is rooted to tooth structures, primarily enamel, which has been etched to provide mechanical retention for the resin cement. The goal of this prosthesis is replacement of missing teeth and maximum conservation of tooth structure. Indications of resin bonded bridges include replacement of congenitally missing tooth or teeth lost by traumatic injuries, especially in young patients. It is also indicated where splinting of periodontally compromised teeth is required. Stabilizing dentition after orthodontic treatment or movement in case of short span and in case of an open bite. Retainers of fixed partial denture for abutment with sufficient enamel to etch for retention, significant crown length, unrestored abutments, and in medically compromised and adolescent patients. Contraindications include patients' sensitivity to base metal alloys, patients with parafunctional habits, long span involving 3 or more abutments, restored or damaged abutments, compromised enamel, significant pontic discrepancy, a deep vertical overlap, when facial aesthetics of abutment require improvement. Example in cases of stained, malformed, or malposed teeth. When there is insufficient occlusal clearance to provide 2 to 3 mm of vertical retention, and in incisors with extremely thin faciolingual dimension. Advantages include minimal removal of tooth structure, non-invasive to the dentine, minimal potential for pulpal trauma, tissue tolerant because of supragingival margins without gingival irritation, aesthetically more appealing since only lingual surface of anterior teeth are covered, no anesthesia, so less trauma to the patient, simplified impression procedures, interim restorations are usually not required, reduced chairside time, reduced patient cost, and rebonding is possible. Disadvantages of resin bonded bridges include reduced longevity of the restoration, enamel modifications are required, good alignment of teeth are required, very thin or translucent anterior teeth are limiting factors because of aesthetics, usually restricted to single tooth replacement, no space and alignment correction, difficult temporization, there's uncertain longevity, and aesthetics is compromised on posterior teeth replacement. Coming to classification of resin bonded fixed partial dentures, these are classified based on the type of retention utilized by the retainers, which also incidentally forms the basis of their development. Retention in resin bonded bridges can be classified as mechanical, micromechanical, macromechanical, and chemical bridges. Coming to Rochette bridge, this follows the mechanical retention type. A Rochette bridge consists of a pontic connected to a metal wing retainer which covers the lingual surface of the abutment tooth. Within the wing, countersunk holes are cut which allow retentive composite plugs to form when the bridge is cemented. When Rochette bridges were originally described, they were designed to act as permanent fixed prosthodontic restorations. However, to achieve composite plugs of adequate strength, they had to be of significant diameter and depth, the latter necessitating a thick wing which caused problems in relation to occlusion, especially when placed in upper anterior region. In addition, occlusal stresses were concentrated on a limited number of composite plugs, predisposing them to fracture, and as such, retention rates were often poor in the long term. Advantages of Rochette bridges are that it is easy to see the retentive perforations in the metal. If the bridge must be replaced, the composite resin can be cut away in the perforations to aid in the removal process, and no metal etching is required. Disadvantages are the perforations would weaken the retainers if improperly sized or spaced. The exposed resin is subjected to wear, and it is not possible to place perforations in the proximal surface or in the areas of the rest. Next is the Maryland bridge, which uses micromechanical form of retention, that is through electrolytic etching of nickel chromium and cobalt chromium alloys. Advantages of Maryland bridge is that it has improved bond strength, or it is at least reported to have improved bond strength. The retention is improved because the resin to etched metal bond can be substantially stronger than the resin to etched enamel. Instead of perforations, the tooth side of the framework is electrolytically etched, which produces microscopic undercuts. It can be used for both anterior and posterior bridges. The retainers can be thin and still resist flexing. The oral surface of the cast retainers is highly polished and resists plaque accumulation. Disadvantages of Maryland bridge are that although this design has been reported to be stronger, it is more technique sensitive because the retainers may not be properly etched or may be contaminated before cementation. Because the retentive features are not seen with the unaided eye, the etched surface must be examined with a microscope to verify proper etching. The next in resin bonded bridges will be the macroscopic mechanical retention resin retained FPD or the Virginia bridge. This method, known as lost salt technique, involves fabricating particle roughened retainers by incorporating salt crystals into the retainer patterns to produce roughness on the inner surfaces. The procedure: the die is lubricated and sieved cubic salt of 150 to 250 microns is sprinkled on the surface, leaving out the margins. A resin pattern is now constructed over the salt, allowing it to get incorporated in the resin. The salt is then dissolved by placing the set pattern in an ultrasonic cleaner. The advantages are the procedure can be used with any metal and bonding to metal superior to electrolytic method. The disadvantages are the thickness of the retainer is increased to allow for retentive layer. The next is the cast mesh fixed partial denture. This particular type of resin bonded bridge utilizes a non-etching method after casting. That is, they produce roughness before the alloy is cast, or utilize a net-like nylon mesh on the lingual surfaces of the abutment teeth on the working cast. This is covered by and incorporated into the retainer wax pattern, producing a mesh-like surface when the retainer is cast. This eliminates the need for etching. Disadvantages are adaptation of the nylon mesh to the cast is not good. The wax may flow in between the mesh, locking all the undercuts. The retention of the metal to the resin and all the above types of resin bonded fixed partial dentures can be improved with silination or air abrasion with aluminium oxide. Now we'll be discussing about fiber reinforced composite resin fixed partial dentures, which is also a type of resin bonded bridge. This consists of a fiber reinforced substructure. It is veneered with composite material. Increased flexural strength, fracture resistance, and increased tensile strength are the advantages of the fiber reinforced composite resin fixed partial denture. It is translucent and thereby is aesthetically very pleasing. The procedure involves preparation of the abutment tooth, measurement of the fiber length, moistening of the fiber. The fiber bar is later pressed into the preparation and polymerized with resin, pontic buildup and curing. Next will be the Fung bridge or Fung shells, which was introduced by Fung in 1998. It consists of a prefabricated pontic with a channel inside it. The channel permits the placement of bridge post. If you have a look at the picture over here, on top is the anterior Fung shell, the second one being the posterior Fung shell, the third one is a Fung bridge with the post. Advantages of the Fung shells are it is of lower cost compared to custom made resin bonded bridges, no need of impression making and laboratory work, can be given to the patient in a single appointment, good aesthetics and no exposure of metal in the proximal areas, and longevity comparable to resin bonded bridges. Disadvantages are that the longevity is questionable and requires occlusal adjustments. Indication includes single tooth replacement and it is contraindicated in teeth with large pulp chambers. The next that we'll be discussing about are about the adhesive bridges, which make use of chemical retention or tin plating. Tin plating is a recently introduced procedure that can improve the strength of adhesive cement to most metals. These are now the most commonly used methods for bonding the resin cements to metal. Precious alloys can be plated with tin and used as frameworks for resin-retained fixed partial dentures. Tin forms organic complexes with several specific adhesive resin cements that result in significantly greater bond strength. Their high bond strength, fracture toughness, and long-term clinical success have rendered alloy etching and macroscopic retention mechanisms obsolete. Coming to fabrication of resin bonded fixed partial dentures. In fabrication of resin retained fixed partial dentures, all three phases are necessary for predictable success, which includes preparation of the abutment teeth, design of the restoration, and bonding of the restoration. Whether anterior or posterior teeth are prepared, common principles dictate tooth preparation design. A very important factor in resin bonded bridges is abutment selection. So when it comes to abutment selection, the abutment must be caries free, should be periodontally sound, must have adequate thickness of enamel, and there should be one abutment on either side. Factors influencing retention in resin bonded bridges are the total surface area bonded, the quality of the bond, the strength of the materials, the direction and magnitude of the dislocating forces, and resistance to torquing. Resistance to torquing can be minimized by the framework design, which will include buckle wraps, retentive slots, occlusal rests, and sufficient clearance. The burrs that we will be making use of in the preparation for resin bonded bridges are the round tipped diamond, inverted cone burrs, and tapered Fisher carbide burr. Gingival margins and circumferential preparation are easily accomplished with a chamfer or round tipped diamond, The occlusal and incisal rest seats can be prepared with a diamond or carbide inverted cone burrs, and additional retentive features such as slots, grooves, or pinholes can be made with the tapered fissure carbide burr. Coming to anterior tooth preparation and framework design. In designing an anterior prosthesis, the largest possible surface area of enamel should be used that will not result in compromise of the aesthetics of the abutment teeth. The retentive retainers should extend on one tooth mesially and distally. The gingival margin should be designed so that there is a slight supragingival chamfer. A rest seat is then placed in the cingulum area of the abutment tooth. This may consist of ledges similar to those incorporated in a pin ledge preparation, or it can be a notch or flat plane perpendicular to the long axis of the tooth. The objective is to provide resistance to gingival displacement and to add rigidity to the casting. Rest seats are prepared with an inverted cone burr to facilitate internal refinement. The framework is extended labially past the proximal contact point to prevent torquing forces from dislodging the prosthesis to the lingual or the palatal side. Anterior design principles. It should have a vertical and a single path of insertion. There should be a proximal wraparound of around 180 degrees. Extension of framework onto the uninvolved marginal ridge. Definite finish line. Cingulum notches or countersinks, grooves, and existing restorations may be incorporated. This slide shows you the anterior preparation sequence where the finish line is first done, followed by an optional slot of 0.5 mm in depth, which can be prepared with the help of a tapered carbide burr. It is good to leave the margins about 1 mm for the incisal or occlusal edge and 1 mm supragingival if possible. Coming to posterior tooth preparation and framework design, the basic framework consists of three major components: the occlusal rest for resistance to gingival displacement, the retentive surface for resistance to occlusal displacement, and the proximal wrap for resistance to torquing forces. Posterior design principles. It should have a distinct and a single path of insertion, proximal resistance form, proximal wraparound of 180 degrees, maximum bonding area, occlusal rest, a definite gingival margin, two-plane reduction for maxillary molars, extension of casting onto the occlusal surfaces, lingual cusp coverage, and onlay on tilted molars if any. This slide shows the sequence of posterior tooth preparation for resin bonded bridges. To resist occlusal displacement, the restoration is designed to maximize the bonding area without unnecessarily compromising periodontal health or aesthetics. The first picture here shows the proximal and lingual walls are reduced to lower their height of contour to approximately 1 mm. The proximal walls are prepared so that the parallelism results without undercuts. The second picture shows spoon-shaped occlusal rest seats which is placed in the proximal marginal ridge area of the abutments adjacent to the edentulous space. An additional rest seat may be placed on the opposite side of the abutment tooth. In general, the preparation differs between the maxillary and mandibular molar teeth on the lingual surface only. The lingual wall of the mandibular tooth may be prepared in a single plane, and the palatal surface of the maxillary molars dictates a two-plane reduction due to taper of the centric cusp in the occlusal two-thirds and occlusal function. Impression procedure. Impression making is similar to any other fixed partial denture. Elastomeric impression materials are indicated, and a single impression technique, double mix using putty and light body, is preferred as the amount of tooth preparation is minimal. Coming to the cementation procedure, Once the prosthesis is ready, it is first sandblasted, washed and dried. An alloy primer is applied to the internal surface of the metal restoration, and the etchant gel is applied to the tooth for 10 seconds, rinsed and dried. And then it is gently air dried. The mixture is then applied to the sandblasted metal, and any excess cement should be removed. For easy cleanup, partially light cure the excess cement for 2 to 3 seconds and then remove the excess. Then a self-cure material by applying OxyGuard to the margins and wait for 3 minutes. Light cure the margins. Maintenance and recall. Resin bonded bridges or resin bonded restorations should be reviewed and maintained through periodic recall appointments. Any signs of debonding, if detected early, can prevent unnecessary damage to the abutments. Periodontal health should also be reviewed and maintained due to the propensity of the retainer to accumulate plaque and over contouring of the lingual surface. Causes of failure in resin bonded fixed partial dentures. The main reason will be inappropriate patient selection, that is, in patients with malalignment of teeth resulting in a poor path of insertion, in patients with short abutments, thin abutments, in patients who have inadequate enamel for bonding, history of metal sensitivity, and in patients with heavy occlusal forces. Causes of failure other than patient selection include insufficient preparation and bonding failure. Insufficient preparation include inadequate proximal and lingual reduction, less than 180 degrees extension of the retainer, and lack of clearance in protrusion. Bonding failure may be caused because of contamination, prolonged mixing, and inappropriate fluting agent. To summarize, resin bonded prostheses are viable prostheses in select situations. They should receive the same attention to detail as a conventional fixed partial dentures for long-term success. Patient selection is vitally important, and the tooth preparation or enamel activation is mandatory. Although newer metal-free ceramic resin bonded bridges show promising results, we have to wait for long-term results to replace the conventional metal resin bonded restorations. These are the references, and thank you.